double factoring because you just factored once. Now we're going to factor again. Do you see that both of these have an x plus 3? There's two terms here, but they've both got an x plus 3.
Mm-hmm.
So you factor out the x plus 3. You pull that out of both terms. Sorry, I got the wrong color here. X plus 3 out of both. And then what's left over? Well, it's the x squared minus the 4, like that. If you're thinking, oh, I hope I don't get one of these on this test, you're going to get one of these on these tests. This is fairly straightforward.
Oh yeah, well, what I have here is the pre-test. So whatever here is pretty much whatever's on here is pretty much exactly what's on the test.
Yeah. So ask your questions. Let me know what if you got issues. So you might think, oh, I'm done, right? Like, yeah, this is great. Like I did the factor by grouping, but wait, there's more. This on the right here is difference of squares. Do you remember how to factor difference of squares?
Would it be x plus 2 and x minus 2?
Yes.
Yeah.
Okay. So all that work, right? All that work just to factor the numerator. Now you need that. You need that. You got to be able to do that. And you want to do it first because you really can't go much further without that. Like that there. Okay. So now I'm just going to move this down and kind of restart the problem. And there's a lot of side work. I mean, you could do all this pretty compactly, but the point is you get this factored form of the equation. So thing number one that we always talked about is domain. Okay. And I don't even know if it asks for that. It does not ask for that. So we'll skip that. Second thing we talked about are holes. Are there any holes, Jadon, in this?
Yeah, there is.
Where is the hole?
X equals -2.
X equals -2. Now to get the y value, you use the reduced form. So we're going to write the reduced form next. X plus 3, x minus 2 over x plus 1. And you have to take that -2 and plug it in for x. So you get y equals -2 plus 3, -2 minus 2, -2 plus 1. So one of the nice things about factored form is you just get numbers inside parentheses that you can multiply and divide. And this one works out really nicely. Gives you +4.
This is a hole at 2, 4.
Yes.
Or -2,
4. Yeah.
Yeah.
So at some point I got to make a graph here and do that. One of the problems is like we've got a bunch of other stuff to do already. So let me try and do it here. See how well I get. Okay, so there's your hole, -2, 4. After you do a hole, we talked about doing vertical asymptotes. Are there any vertical asymptotes in this one?
Yes.
Looking at the bottom, where the bottom equals 0, where x plus 1 equals 0.
Oh yeah, so x equals -1.
Yes, and it's always an equation of a line. So x equals -1. Then I mentioned putting some arrows like that. Okay, now do you remember what we do next after vertical asymptotes?
Horizontal asymptote.
Yeah, now we have not talked about this case yet. So the issue here is that the degree of the numerator is 2 and the degree of the denominator is 1. So if you were to FOIL the numerator, and we do need to do that now, x squared plus x minus 6 over x plus 1. You can see that there's a power of 2 in the numerator, power of 1 in the denominator. So this is not any of the cases that we've seen. I call it case 3. And this is where you have to use polynomial division or synthetic division. You have to divide because it has a slant asymptote. So whenever the degree of the numerator is greater than the degree of the denominator, it has a slant asymptote. Now, did your instructor specify whether you could use synthetic division or long division?
He wanted us to do long division.
Oh, that's awful. Okay, well, that's what you have to do. All right, so you write x squared plus x minus 6 inside the house. Outside the house is the bottom x plus 1, and you ask yourself, you say, hey, what do I multiply x by to get x squared?
X.
Yeah, and the answer is x, yeah. And then you multiply x by each of the things over here on the left. So you get an x squared plus x. And then this is my preference. I call it change the signs because I like to add instead of subtract. So if it's positive, it becomes negative. If it's negative, it becomes positive. This one's positive, so it becomes negative. This one's negative, like that. And then you subtract here. So actually, these both cancel 0 and 0, so you bring down the minus 6. And that, oddly enough, so this one's usually you don't get usually you get like an x here and you end up having to do this again, but there's nothing else to do. So this is your remainder down here in the bottom. This is your quotient and this is your divisor. But your horizontal asymptote is whatever's up in the quotient. So in this problem, you're like, maybe you're thinking, well, what does he mean by that? It means your horizontal asymptote is y equals x. So you now have to go back to your graph and graph that line. It's always a line though, like it's never anything weird. It's always a line. So it might be like x plus 1 or minus x minus 1. If you remember how to graph a line, you need the slope and the intercept. This is a slope of 1 and a b value of 0. It goes right through the origin there. So you have something like that. Hopefully you've seen that in class.
Yeah, I have.
Okay. Okay, so nothing new here. Now arrows go at the end again because it's gonna connect somewhere. We don't know where. We'll figure that out next. But sometimes your horizontal asymptote is a slant asymptote. It's either one or the other. It's either horizontal or it's a slant. Okay, and then we move now to x-intercepts and y-intercepts. So let's do that. Let's go down here. So y-intercept was when x equals 0. And so you've got 0 plus 3, 0 minus 2 over 0 plus 1. So 3 times minus 2 over 1 is negative 6. So that's a point on your graph. X is 0, y is negative 6. So we'll go back to our graph. 0, negative 6, 1, 2, 3, 4, 5, 6. So not really to scale. We'll see. Okay, and then the x-intercepts. Do you remember how to find those?
Yeah, I'm gonna have to think for a second.
So the x-intercepts come from setting the numerator.
Oh, the 0. Yeah, you set the numerator 0.
Numerator equals 0.
So would it be both of them in the numerator, like the x plus 3 and
Yes.
the x? Okay.
Yes, so there's actually 2 in this problem, which we hadn't seen before, but it's possible.
Okay.
So we go back to the graph now, and we at -3 and 2. And this is where we talked about before, you kind of have to like connect the dots a little bit. Now the graph I've made really isn't to scale, but I'll just connect them here to try to help out. So this connects with this one, it connects with the y-intercept, and then it goes down like that. So obviously this needed to go like that. And then similarly with the hole, it connects, and then again, like it's not to scale, but it would look something like that. It would go down to this slant asymptote. Any questions on that?
So he actually doesn't want me to. He actually doesn't want the domain. So for like the slant asymptote,
Yeah,
how would like I write the answer for that? Because it asked me what that is.
right here, y = x.
Okay. Let me just write that down.
And the only way to get it is to do the division.
Yeah, I graphed it on my calculator and it looks right.
Yeah.
Ooh, okay, it's a lot of work for one problem.
Yeah, I mean, your quiz you said was 2 questions.
Well, yeah, the test is 3.
Yeah, it's not there's not that many. It just you've got too much going on here. And you should do well because you know how to do all these questions now. You know that it's just working through all the steps. You know, making
Yeah,
sure.
the only thing I got, so at the quiz I took, the only thing I got wrong was, for some reason, for the whole, he only wanted the x-intercept. He didn't actually want the point, so he marked me wrong for that.
Well, I think you did the right thing though. You know, finding the y value. It's
Yeah.
it's a little odd that you wouldn't want both, but you know, always know that going into the test quizzes, you know, what did they want? Give them what they want.
Mm-hmm.
Okay, so do you have another problem for us to look at, or do you need me to make one up here?
Can you make one up? Because the ones he gave me were just factoring the top pretty much. He didn't actually give me full questions.
Do you want do you know, sometimes like instructions will say like the first question is going to have a horizontal and a vertical asymptote, and the third one's going to have a slant asymptote. Do you know what style of questions you might get?
Yeah, so the first question is going to be the one that we started out with, where it's like, the simplest version of this. The second one is the one where it's like x squared on both sides, and the third one is the one we just did.
Okay. Let me okay, here's a problem we can look at. Okay, so here's our problem. So like right away, you want to look, I know we said we had a factor, but you right away want to look at the degree, because that kind of also hints you in. So see how the degree of the numerator is greater than the degree of the denominator.
Yeah.
Okay, but now we really want to factoring, and there's a bunch of different types of factoring they could give you. There's no way to know which one it would be. In the numerator, you should notice that x goes into everything. X is the greatest common factor, so that becomes x squared minus x minus 6. And in the bottom, there's actually a -3 that goes in everything, x squared plus x minus 6. So I'd like you to factor what's inside parentheses in the top and the bottom for me. Small variation between them.
So it'd be x minus 3 times x minus 2, and then the bottom would be x minus 2 times x plus 3.
So the top and bottom both have to be opposite in signs. And I heard
Yeah.
-3, but so one's got to be positive and one's got to be negative. So the top is x minus 3, x plus 2. And the reason is that inner term, the outer and the inner term has to be -1x.
Yeah.
Okay, and then on the bottom, it's the same thing. It's positive 1x, which means they're opposite in sign, x plus 3, x minus 2. Okay, and then that'll mess up your entire graph. So just really be careful. You could even FOIL just to make sure that you get it right. Okay, so question to you is, does this have any holes?
I don't think so, no.
So no, it does not. But the way you had said it, you might, and that would throw everything off. Everything would have been, because if you had said x plus 3 or x minus 3, x minus 2, you'd cancel and say, oh, there's a hole. Are you going to be allowed to use your calculator?
Yeah.
Okay, so your calculator, I would graph this before I did anything else on the calculator, so I knew the target. All right, so there's no holes. Are there any vertical asymptotes?
Yes, right?
They're where you set the bottom equal to 0. The denominator equals 0. So tell me what those two vertical asymptotes are, please.
It'd be x equals -3 and then x equals +2.
Yes. Okay. So that's where we got to start graphing. So I got to graph here. Okay. So what did we say here? -3 and +2. -3, boom. +2. All right, and then I really do still recommend the arrows. Okay, so now we go to horizontal asymptotes. So I already mentioned this before. It's the degree of the numerator over the degree of the denominator. All right, and this one is awful. You do have to use that. This one you have to use polynomial division. The previous one you had a choice. So this one goes outside the house. Make sure you write it correctly. I almost wrote it wrong. And that's another reason why you're only given a couple problems here, because you really can mess up pretty bad here and go sideways, and then the whole thing is wrong. There's very little partial credit. So notice I put a 0 here at the end, just as a reminder. You're supposed to have all the terms in descending order. So like a 3, a 2, and a 1. And even the constant term.
Yeah.
This one doesn't work out all that nice, and I apologize. I'll help out here. So we need to multiply. We need to multiply 3x squared by something to get x cubed, and you wouldn't get one like this on your test, but it's -1/3 x. Okay, -1/3 x. And that does work, because that gets the negatives cancel, the 1/3 cancels 3, the x squared times x gives you x cubed. And then we move along here. So negative 1/3 x times 3, negative 3x gives you positive x squared. Okay. But again, you change the sign, very important here to do that. So it becomes negative, negative. All right, so that's first one should always cancel. The second one doesn't always, and then you bring this down. So then you ask yourself, what do you multiply minus 3x squared by? Or I'm sorry, what do you multiply x cubed by? I'm sorry, what do you multiply minus 3x squared by to get minus 2x squared? And the answer again is it's not great, but it's minus, actually, it's plus 2/3. And I know you're going to get one with whole numbers. I doubt they do this to you, but I just grabbed this randomly off the internet. So, we don't know what we're going to get. And actually, I apologize here. I didn't bring this constant down. I really messed this. I really fumbled this. Okay, sorry about that. Let's go back to the minus 1/3 x. You have to multiply it by the 18 as well. So you get minus 6x. And then, but then when you change the sign, it ends up canceling out and you get 0. The truth is, though, nothing matters down here. The only thing that matters is this up here, because this is your slant asymptote. Okay, so you actually can stop at this point. Most students don't, but really you have everything you need up here. This is your slant asymptote. Okay. So what you're essentially, what they're really looking for is like the slope roughly on this one. So it's got a 2/3 b value. Okay, great. But the slope is minus 1/3, minus 1/3. And you need to get it, you need to get a few points in there. And then something like that. So you're again, just something like this. Again, I'd put some arrows at the end. Do that. Okay, so we've done holes, there's no holes, we've done vertical asymptotes, and we've done horizontal asymptotes. Now we're up to x-intercepts and y-intercepts, and that's why you need this factored form. All right, so let's go down here. So let's do x-intercepts first. I'm sorry, y-intercepts. We've been doing y-intercepts first. So that's when you set x equal to 0. So you get 0 times 0 minus 3 times 0 plus 2 over negative 3, 0 plus 3, 0 minus 2. What you should notice right away is that the numerator becomes 0. So that means it's at 0.
Yeah.
So there's a y-intercept is at 0, 0. So go back to your graph. There it is right there. Now, how about the x-intercepts? What do you do for those?
You set the denominator equal to 0.
Numerator.
Oh, numerator, yeah.
Top, yeah, the top. And sometimes it's better to go top and bottom rather than numerator and denominator. So you got three things there. You got x equals 0, x minus 3 equals 0, and x plus 2 equals 0.
So it'd be x equals 0, positive 3 and negative 2.
Yes. We already have the 0, 0 from the y-intercept, but we need the 3 and the negative 2. So you go over there, there's 3, there's negative 2. Doesn't look quite right. This one, I'm going to graph. If you got your calculator handy, I would recommend graphing it. This one might have some stuff in it that I didn't anticipate when I gave the problem to you, but we'll see here. X. Okay, we're actually fine. It's just that this one really is kind of diabolical for you. So the problem is at this point, Jadon, did you graph this on your calculator? Sorry, I should let you get caught up.
It's showing up right now.
Okay.
Yeah, I got it.
Okay, so you're gonna see something on your calculator like the following. Let me get this snipped in without the color. Maybe you got a color calculator. So we're right on track here. There's the slant, there's the verticals, there's the crossing, right? So the question is now, like, how do you figure out the other stuff? It's like, well, that's a harder question to answer, because you're really supposed to test points. But since you've got your calculator, like, I would just tell you to fill it in. I wouldn't, I don't think your instructor even says to test points.
No, he'll let us do that.
Yeah, so you've got everything. You're like, all right, as bad as it was, even with Matthew making some mistakes there, still kind of got it to look the way it was supposed to. And this one's got like a funky thing going on there, which you'll learn in calculus. If you take calculus, you'll be able to get your right answer on that one. So you can see the second problem went a little faster than the first one.
Yeah.
But you can see you can't, we can't do that many in a lesson. You can't do that many in an hour. So do you get a full hour for your test, or 50 minutes?
It's probably a full hour.
Yeah, so you can break up your time. You can go 20, 20, and 20, 10, 10, and 10 with some buffer. But you probably want to pay attention to the clock and say, all right, well, I better move on to the next one and come back to this one if you're running into issues.
Yeah, I only have one of these ones. The other two are the easy ones that we did last time.
Okay. All right, let's do you want to do another one of these types to make it slightly easier?
Yeah.
Okay. I think this one's slightly easier. Excuse me. Okay, so here's number 8. And not number 8. Here's another question. What I always, I said this in previous round, but I like to look at the exponents, because that tells me slant asymptote. Like, slant asymptote, no good. But you always start by factoring. So in the numerator, what is common to both an x cubed and a 9x?
An x.
X. What goes in parentheses?
X squared and then -9.
X squared minus 9. Yeah. Okay. And you should say, oh, difference of squares, or at least, you don't have to get that excited, but you have to be like jumping out of your seat. Like, I know what to do. The bottom, there's a 3 that factors in everything. So you always look for a GCF, greatest common factor. It's always the first type of factoring you do. While you could do the bottom as a non GCF problem, you're just making more work for yourself. So don't do that. In the top, can you tell me what the difference of squares becomes?
X plus 2 and then x minus 3. Or x plus 3 and then x minus 3.
Yes. Okay. And then you're headed towards the bottom. Could you factor the bottom for me and tell me what the result is?
X minus 3 and then x plus 1.
Okay. And how positive are you? How certain are you of your result?
Pretty certain.
Okay. Because here, I'll point this out here. Let's just say, so let me point this out here. There's a hole at x minus 3.
Mm-hmm.
Okay. But if you flipped it, if you got x plus 3, x minus 1, there's then a hole at x plus 3. One is completely right, one is completely wrong. And you are correct. This is correct. It's x minus 3, x plus 1. Just really be careful here, because your calculator won't show you the hole. Well, it kind of can. It actually kind of can. How do I want to do this? Do you want me to show you how to check the calculator for a hole?
Oh yeah, definitely.
Okay, okay. So let me pull something up real quick to be able to do that. I've got a calculator, a virtual TI that I can show you here. Okay, let me share screen. All right, so you're seeing my virtual TI, whatever. So what I want you to do is go to your y equals, and I want you to graph this thing, x cubed. Why am I struggling here? Because it's early. Minus 9x divided by 3x squared minus 6x minus 9. Okay. Let me know when you've gotten this far. If you got a T84 or whatever, you can graph it another way, but I got to do it the old way where it's with parentheses and stuff.
Yeah, I got it.
Okay. Now, a couple of things here. You can try graphing it right away, but one of the things you should always do, especially if you're doing a bunch of different graphs, is you should always go back to Zoom Standard 6, just in case you made any manipulations to your window. Okay. And these graphs are awful. I mean, that's why we don't use this thing. Okay. Now, to check for holes, I'm going to go to second calc. Calc is above trace, second calc. Okay. And I want to calculate a value. All right. So I'm going to hit enter. And notice it says in the lower list is x equals. Now we know there's a hole at 3 from what we did on the previous screen. So when I type in 3 here, do you see how there's no y value?
Yeah.
That's because there's a hole there. Now let me do this again. Let's say we messed up and we're like, oh yeah, there's a hole at minus 3. Do you see I get a y value?
Y equals 0.
Yeah. Now let's try the vertical asymptote as well. So let's do a second calc value because there's a vertical asymptote at -1, not 11. And then you hit enter. See how you also get 0? So it's not that it's telling you there's a hole. It's that you should say, oh, there's nothing there. So it's either a hole or an intercept. And because you can kind of see that there's one at -1, the -3 should jump out to you, or the +3 should be the one. You can also do some things like tracing, but it doesn't, you'd have to be right on there. And then there's also the table. So let's go to the table. It's another way to do this. So sometimes though, your instructor will, you manipulate tables in class. Okay. We're going to just use the default values here. So we go to second table. Okay. And then what do you notice at 3? What does that y value say?
Error.
Error. So, but we don't know that's a hole. It doesn't say hole. I mean, we'd love that, but it doesn't say that. And then if we go back to -1, what does it say? Same thing.
Error.
So you gotta be careful there. Error either means hole or vertical asymptote. But that's potentially helpful for you to verify your answers. Is that okay?
Yeah.
Okay, so I'm going to go back to the other screen. If you ever have any other questions about how to use your calculator, I can definitely help with that. So we already sort of answered this, but the vertical asymptotes, I'm sorry, the hole, what am I doing here? The hole, there's a hole at x equals 3. Notice the calculator does not give you the y value. You have to do that by hand. It just tells you error, or it tells you nothing, which is it's kind of frustrating, but these are machines. Machines don't know what you really want. So you put 3. Oh, you don't even have to do this. That's really odd. I don't know why you don't have to do this. It's such a normal thing to do. So it ends up being 3 halves. Because I always like to plot the point on the graph. I always like to go right to my graph, 3 halves, boom, there's a hole there. But I'm not grading your test, so. Okay, vertical asymptotes are when the bottom equals 0. So when x plus 1 equals 0, you only set the x terms equal to 0. You don't set the 3 equal to 0. So that's at x equals -1. We saw that in the graph. Make sure you label that. And then horizontal asymptotes are next. So this is where you take the reduced form and you have to divide. So this is a slant asymptote. I don't remember if you can actually do the original, so plus it's more work, so I wouldn't do that. But we need to multiply the top, and then we do need to multiply the bottom. And then 3x plus 3 goes outside the house. X squared plus 3x plus 0 goes inside the house. I add that 0 because you're supposed to fill in all the descending spaces when you do this. X squared, x1, x to the power of 0. Oh, and this one again doesn't work out all that nice, but you ask yourself, what do you multiply 3x by to get x squared? And again, it's
1/3 x.
yeah, 1/3 x. I hope you don't get one like this, but I don't know. So that's x squared plus x. Change the signs. That's instead of just subtracting. I really prefer this. Okay, so then you subtract and you get 2x plus 0. And then you ask yourself the same question as you did before. What do I multiply 3x by to get 2x? You're always focusing on that leading coefficient. And that's 2/3. Wow, another one with exactly the same slant asymptote. Well, I guess this one's got a positive slope. So you can stop here. You can stop right there because that is your slant. You don't care about the rest. You don't care about the remainder. You just care about getting the equation of the slant asymptote. 1/3 x plus 2/3. So 2/3 is there. Huh. Is that right? Yeah, I guess it is. Okay. So the up 1/3, that looks pretty good. 1/3. You're just trying to get a rough gauge of where this thing is. Like that. And then you go to you go back to the factored form. You always go back to that reduced form. And now we look for y-intercepts and x-intercepts. So I'd like you to calculate the y-intercept and then the x-intercepts for me, please.
The y-intercept is setting everything to 0, right?
The x goes to 0.
Okay. Ah. It's a y-intercept 0.
Yes.
Yeah. And then the x-intercept, you set the numerator to 0.
That's right.
Okay. And then you get x equals -3.
0 and -3.
Yeah.
Okay, so we go back to our graph. 0, 0, -3. And then you've already got the you've already kind of got the graph there. So you're like, all right, that connects like that, something like that.
Yeah, that matches the graph.
Yeah. Okay, so let's do some rapid fire problems here where I ask you to find various things from a graph, and just for review here. All right, so let me know when you're ready. We'll look at kind of a simple one.
I'm ready.
Okay, are there any holes?
No.
No. Where is the vertical asymptote?
X equals -2. Wait, no.
Yep.
Oh, yeah.
Set the bottom equal to 0. This one has a horizontal asymptote at y equals 2/3. And the reason we know that so quickly is because the degree of the numerator and denominator are the same. So it's the ratio of the leading coefficients. Where is the y-intercept? Tell me the y-intercept, please.
Hold up. -2. Is it -1/3?
Yes.
Yeah.
And now I want you to tell me the x-intercepts
Or
or intercept.
X equals 1.
Good. Okay. All right, let's try another one here. All right, I want you to factor the denominator for me.
X plus, wait, no. X plus 1 and X minus 1.
Okay. You need that to answer some of our questions here. So first question is are there any holes?
No.
No. Are there any vertical asymptotes?
Yes.
Okay, so to find them, you set what equal to 0? Which
The
one?
denominator.
Set the bottom equal to 0.
Yeah.
Okay, so give me those equations, please.
X equals -1 and X equals +1.
Okay, very good. Horizontal asymptote. What is the degree of the numerator?
1.
And what is the degree of the denominator?
2.
2. So
Yeah.
this is the case where it's y equals 0 because the degree of the numerator is less than the degree of the denominator. You got to remember all three cases. I know you'll have a graph. I mean, you'll see everything trend towards y equals 0 on it, but you want to be able to look at it too and be able to see that. Okay, next one is y-intercept.
It'd be 0, right?
X equals 0, yeah.
Yeah.
X equals 0, y equals 0. Last one is the x-intercept.
It'd be X equals -1 and X equals 1.
The x-intercepts are saying the numerator equal to 0.
Oh, wait. X equals 0.
Yes.
Yeah.
So the only place you can have duplication in is the x-intercept and the y-intercept.
Yeah.
You can't have like a vertical asymptote and an intercept, a vertical asymptote and a hole. Like that's the only one that you can double up on. All right, well, that's it for today, Jadon. If you got some time, review these notes tomorrow before your test on Monday and maybe some of the other lessons we've done. And I think you'll do great. So appreciate you scheduling and hope you enjoy the rest of your Saturday.
You too.
Okay, bye now.
Bye.